Hey folks, welcome back for another episode of Code Club. In today's episode, I think I have a really cool data visualization that I really just can't wait to build out with you. I received a link to this YouTube video a month or so ago from Eric Hill. Eric, as I understand, is a researcher out in the Pacific Northwest of the United States. He's really interested in data analysis when it comes to long distance running. Eric's son is an accomplished cross-country runner in high school. I think maybe by now he has graduated. And so Eric is really interested in making predictions and all sorts of other things around data analysis of running data. It's kind of like sabermetrics for baseball, but now for running. And it's really cool to see that type of data analysis approach that previously was done for baseball and popularized by books like Moneyball and whatnot, now being applied to basically every sport there is. And so Eric sent me this video. He mentioned that he tried to make it in R with ggplot and other tools, but never quite got it to work that he wanted it to. He then went about building it out in P5.js, which is a JavaScript library. And again, he offered it to me as a suggestion for a cool video or a cool data visualization that I might try to recreate here in R. As you can see, each of the points is a different runner or percentile of runners going through. The green dot that we see here is Peyton, which I believe is Eric's son's name. The red is the fastest runner. This teal is the 99th percentile and kind of all the way on back. And so we have the course that we can see up here. We also have the change in elevation along the progression of the race course down here at the bottom. The other thing that we have is this table of percentiles along with how far they've run. And we also then see how long they've been running for, as well as Eric provides a little bit of commentary here in the chat. I think this chat is really cool as a way to provide a commentary to this animated visualization. So when I started thinking about how I might make this, a couple things jumped out at me right from the get-go. I'm going to go ahead and pause it here. But that we see this course, right? And I thought, oh, wow, I'm going to need like all sorts of GIS types of information. And I thought, no, I don't actually. I just need to know where the points have traversed, and I can make a line plot using those points, right? So this course is effectively a line plot with runner data on top of it as a point, as a scatter plot, really, right? And then we can think of it as being animated across different time or different distances run. Down on the bottom then, where we have the elevation, is a line plot again, right? Where we can see kind of the elevation change of the course with each of the runners, or, you know, if we're going to focus in on Peyton, I have the data for Peyton, which I think he's already kind of run off the course, completed the race, that we could imagine animating Peyton's movement up and down across the elevations. The third component to this then is this table of percentiles along with how far they've run. And so this is something we could perhaps do with something like geom text, right? So again, I thought this was really cool, and I could imagine taking like Patchwork, which is a great R package that works well with ggplot2, as well as base R, for composing different figures together. Another cool tool that we would use would be something like gganimate. Gganimate makes it easy, so I'll put that in quotes, easy to animate a data visualization. And so perhaps those tools could come together. Alas, as I was doing more and more research, I realized that those tools can't come together. However, there's another great package called magick, M-A-G-I-C-K, that is a encapsulation of the ImageMagick tool. ImageMagick is a great tool for manipulating pictures and other image type files. And so what I could imagine doing is making 3 different animations for the 3 different parts of this visual, and then using ImageMagick to pull them together. And so that's what we're going to do in today's episode. Now, I got data from Eric, and what he provided me with is the longitude, the latitude, the elevation, the distance run, the time for Peyton, right? And so I don't have all the other percentiles, and I could go about kind of simulating these other percentiles using some type of distribution of sorts, but I'd rather use some of the data that he gave me. And so he also gave me other information like the heart rate or the pace or different things about the length of the stride of the runner. And so what I'm going to do is really regenerate this animation. But instead of this table, I'm going to put a dial indicating the heart rate of Peyton as he goes through the course. So heading over here to RStudio, I have the file that Eric sent me along with the start of my R script. If you want to get this data file as well as the R script that we generate in today's episode, by all means, go down below here in the description to this video. There will be a link to a blog post that you can go to get all this great information. Also down there is a link to a newsletter email that I had sent out to my subscribers describing this animation and kind of taking a 30,000-foot view of how I would go about regenerating this figure. So this episode is going to be rather, I think, long and involved. And so I encourage you to sit back and enjoy and kind of mentally walk through this with me. And if you want to generate it on your own, that'd be awesome too. So as I was mentioned, this CSV that I got from Eric has the latitude and the longitude. It's in kind of a weird units, but the kind of the spacing of the units is proportional to what you'd get from a more traditional latitude and longitude. There's the distance run, the elevation in feet. There's the elapsed time in minutes, rounded. There's the distance in miles. There's the cadence and the heart rate. So again, I'm going to use the latitude and longitude to plot the map of the course, the distance meters, and the elevation for the figure across the bottom of the animation. And we can then plot Peyton, our runner, across this, perhaps using information about the elapsed time in minutes rounded, right? So we'll want to see what that is. I'd be worried if it's rounded to the nearest minute, because that might not be enough resolution to be interesting. So we'll have to check into that a little bit. And then I'm going to make a dial using the heart rate in BPM. We could use the cadence RPM as well, but I'm going to go with the heart rate because, I don't know, that just seems interesting. You could try the cadence on your own. So let's go ahead and dig into this elapsed time minutes rounded a little bit more closely. Something we could do to take a better look at that time would be to read in the CSV and then pipe that to summary. And so again, we want this is elapsed time in minutes rounded. And so I can see that it is not rounded to the nearest minute, but that perhaps it goes out even to the thousandth place. Another thing we could do would be to, let's go ahead and save this as Peyton. And then we could do Peyton $ elapsed time minutes rounded. And then we get these values that, at least as they're outputted, are going to the 100th place. And so I think that's enough resolution to get a good sense of kind of the time from the start of the race. So I'm going to start thinking about that top panel with the course of the race. And so let's go ahead and take this CSV and we'll pipe that to ggplot AES. And then on the x-axis, and just to remind myself of my column names again, we're going to use latitude and longitude. And so on the x, I believe it's longitude. I always get these two confused. I don't do a lot of stuff with maps, so forgive me if I screw it up, but we'll know soon enough if I have screwed it up. And then we'll do geom_line. Okay, so this generally looks right, having the longitude on the x and the latitude on the y. Again, if we come back to Eric's map, that looks pretty good. But what we're getting here is the result of geom_line. So geom_line will take your data frame and it'll first sort it by the variable on the x-axis. And so we see a lot of kind of vertical transversing of the path, which is why you can see that, right? And so what we want to use instead of geom_line would be geom_path. So geom_path does not do that initial sort of the data by the x aesthetic variable. Now we get the map of the course. Because we're using Peyton's GPS coordinates, if you will, and he doesn't go exactly foot over foot from lap to lap, kind of in this region down here, the lines aren't perfectly smooth, right? There's a bit of a gap. And so one way we can get around that is to make our line width a bit thicker. And so the first thing I'm going to do, though, is I'm going to go ahead and save this as a PNG, because ultimately what we're going to be making is a GIF or a GIF. I won't get into that debate. But a GIF is a bunch of PNG files concatenated together. So we'll do ggsave. I'll do course.png, and then my width. I'm going to put this in terms of pixels because that will work better down the road using image magick equals 1100 and height equals 700. It's warning me that my dimensions exceed 50 inches. That's not right. So again, we want to use units equals px. All right, So the next thing I'm going to do is I'm going to get rid of basically everything except for the path. So to do that, we can come in here and do theme_void, which should kind of remove basically all the ornamentation of our plot. We see that that has cleared everything out. So two things I want to do is to make the background black and to make the path white, or maybe a light gray. So first, let's go ahead and make the background black. So we'll go ahead and do theme, and we'll do plot.background, element rect, and we'll do fill equals black, and then color equals black. And so the fill is the interior of the rectangle, if you think of the background as a rectangle, and the color will be the border. And so there you go. Our line is black. We need to change that to be a light gray. So here in geompath, I can do color equals light gray. There we go. We now have our light gray path on our black background. And now I want to make the line a bit thicker so that I don't have these gaps, as you can see from the different laps of Peyton running the course. We'll do line width, and let's go ahead and do 3. And I think that's a pretty good line width. One thing I would like to do is to maybe round the ends of the line. We can do that with line end equals round. And so that gives us kind of a nice rounded end and start to our map. Now what we'll go ahead and do is add onto this geom_point for Peyton, right? Now what we can see is Peyton's position across the whole course as these black circles. And maybe what I'll do is go ahead and make those circles a little bit smaller, and I will go ahead and make them green like they were in the animation. And so we'll do color equals green. And let's also do size equals 2. Oh, that's too thick. Let's drop that down to 1. Now we have the green point for each of Peyton's journeys through this course. One thing that I think we need to add to this would be a coordinate system, right? And so we need to do chord equal. And so chord equal will make sure that the increment on the x-axis is the same size as the same increment on the y-axis, because latitude and longitude are the same relative sizes, right? Now we have a much more proportional representation of the running course. Now let's start thinking about animating this. And so to animate it, we're going to need to do library gganimate. And so you'll want to make sure that you have gganimate loaded and installed on your computer in RStudio. And so I'll add to the end of this then transition_states. And it's then saying that I have to provide the states. And so that is going to be that time in minutes, which I'm already forgetting what it was called. So let's look at this again. So that's elapsed time minutes rounded. So we'll go ahead and plop that in there. This takes a second to go ahead and generate that animation. And so if we look over here at our window in RStudio, we see our green dot flying all over the place. And it doesn't quite capture the whole window in this small grid on the right side here. But what's happening is that it's animating everything. And so by default, gganimate will animate what is fed in the AES statement within ggplot, right? So it is animating the X and Y position over the different values of elapsed time minutes rounded. However, I want the path, the course, to remain static. And so to do that, I need to have 2 data frames. Of course, I only have 1 data frame, so I'm going to make a copy of this data frame, okay? So I'm going to go ahead and call this Peyton, and then I'm going to have a course that is going to be the same thing as Peyton, okay? And what we can then do is Peyton is what I'm going to feed into this whole thing, and path is going to get data equals course, and then we're going to need a mapping argument, which is the AES statement, right? And our AES then is going to be basically the same thing as this. So we'll plop that in. And the other thing that we'll go ahead and do is inherit.aes equals false. And what this means is that geompath should not be using the aesthetics that are used within the ggplot statement, okay? And so again, we're using Peyton to feed into ggplot to then animate the point. We're using course to provide the data for the boundaries of the course. So let's go ahead and give this all a run and see what we get. All right, so it's still doing the same thing that we saw before. And so to solve that, we need to give course different column names than what we see in Payton. Okay, so Payton gives us the latitude, the longitude, the distance meters, elevation in feet, as well as the elapsed time minutes rounded, and the heart rate BPM. I don't really need that elapsed time minutes rounded, so but whatever. So I'm going to go ahead then and modify this to get different column names. And so we'll use select, and I'm going to do that by copying these names. And so I'll plop that in here, and we'll put each of these on a separate line. So I'll do NXN lat, and I forgot to mention that NXN stands for Nike Cross Nationals, which I understand is one of the biggest cross-country races in the country. So that's what we're looking at here, is data from that. NXN long equaling that, NXN distance equals that, and then NXN elevation equals elevation feet. And so when we run select like this, what we're going to do is we're going to select these 4 columns, but we're going to give it a different name. And so if you look at these now, we've changed the name of our columns. Cool, right? So the other one I want to get, because I'm going to be looking at this heart rate and BPM, I'm going to go ahead and copy that, and I will call this NXN heart rate. Okay, and so now I have course. So now let's try running this again. Oh, it's upset because I changed the name of the variables that I'm mapping. And so instead of position, this should be NXN, and this should also be NXN. And so now here we go. If you look really close, you can see that green dot flying all over the screen. So let's open this up, and you can kind of see the green dot just flying around really fast. So I'm going to go ahead and save this then as a GIF. And so I'm going to save the plot as course. And then we can do animate course, and I'll do width equals 1100 like I had before, height equals 700 like I had before. I then need to set the renderer, so I'll do renderer equals magick render. Okay, so let's go ahead and run this to make sure that it generates our GIF. All right, so I'm noticing that the thickness of my line changed, and I don't know that I can actually see my green dot flying around. And I think that's because the resolution changed. So if we look at the help for animate, we'll see that there's a 3-dot argument. And so this takes arguments that are going to get passed on to the device. So in this case, PNG is the device. So let's look at GR devices PNG. And so if we come down to PNG, we then see res equals NA. So let's go ahead and here then and do res equals 300. 300 is the default resolution for ggsave, I believe. So if we come to ggsave and we look at DPI, that's 300, right? So the default for PNG is 72. So let's go ahead and try this again. And so now that looks a lot more like what we had previously with our PNG, right? It's still moving pretty fast around, but it's at least the right proportion to what we had previously. One thing I'm noticing is that we get kind of this letterboxing effect where we have the white line at the top and the bottom. And that's because we're using chord equal, that it is changing the size of our canvas. And so basically our canvas is too tall for how wide we have it. So I'm going to go ahead and only look at 1 frame. So we'll do n frames equals 1. This should allow the rendering to go a bit faster than it normally does with however many, I think 100 is what it normally does. And so now, again, we have the first frame and we see, again, the letterbox. So let's go ahead and drop this to, let's say, 670. And so we still see a little bit of the letterbox up at the top. So let's drop this down to, say, 665. So that then is too short because now we get the letterbox on the sides. I am going to figure this out so you don't have to watch me going back and forth. And so now you'll see that I don't have any white edges, and this was at a height of 669. One thing that I'm remembering, though, is that I've named the plot course and also the data frame course. That's not what I want. Let's go ahead and call the data frame NXN, and then we'll keep the plot as course. And so then here in data, I need to make that NXN. So let's go ahead and rerun all this to make sure it just works. And then we can run course GIF. Now we can see the black background of our canvas. And if you, you can watch the green ball go flying around the course. We'll slow that down before we're done with today's episode. Okay, so I think this looks pretty good. One thing I would like to do is put some information up here in the upper left corner. So here you'll see that there's like a hashtag, who made it, things like this. I think what I'd like to do is to put in how long, the time, as well as the distance that has been run. And so let's come back up here, and you'll recall that the stuff that gets animated is what is in ggplot, right? So I'm going to come in here and then put geom text. And so then we're going to need a label. And so that is going to be some column, right, that we want to pull probably from Peyton, because Peyton is what's getting animated. So I'm going to go ahead and pipe this to a mutate to create my favorite column, pretty. And we'll do a paste. And let's go ahead and remind ourselves what these columns are that we want. And so again, we want the distance in meters and the what. And I think that the elapsed time minutes rounded. Okay, so we'll go ahead and plop that in. And so to make that pretty column, we'll go ahead and say paste. And actually, let's leave it like this for now and see. So let's just see what that looks like, right? So go ahead and load Peyton. And then our column is pretty. And so we'll put that in here within label. And I think I need a plus sign here for my geom text. And we can do some of this development within our PNG. So let's go ahead and set that up. And so my aspect ratio is kind of screwy. And I'm getting the GIF anyway, even though I try to save it as a PNG. And what you can kind of see is that those numbers are moving by the X and Y position. So we need to do some stuff here to clean this up. And so X, we're going to need to set as well as the Y, and our color is going to be, I'll make that white. And so we need to figure out a proper X and Y position. And so what we want is the label X and label Y. And so we're going to put some R code in here to calculate label X and label Y. So again, if we look at Peyton, and we've got the latitude and longitude. So again, latitude is the Y position. So let's go ahead and take position lat, and we'll look at, say, the range on that. So we'll do Peyton $position lat, and so it should give us the range. So the smallest value at the far left, at the bottom, is 54 through 15 3 6 8 4, and the top is that, right? And so we want something perhaps, let's say, I don't know, 80% to here, right? So how would we do this? So let's go and say this is Y range is that, and then we can say Y range 1 is the bottom, Y range 2 is the top. And so maybe we could do is we could take Y range 2 minus Y range 1, and then let's multiply that by, say, 0.80, and then we'll add back to that Y range 1, and that gets us that number, okay? So let's go ahead and throw this in for our Y, and then we want to do the same type of thing, but for our X, right? And so let's see. I think this code worked, but we'll see. So by the same logic, we'll do, let's try 0.2 times all this, right? And so I think what we want here then is X range. And we'll do that. And then this will be position long. I got one too many L's in there. Okay. And then here we'll do X range for label X. All right. And then let's see what we get for label X. Label X is that, and label Y is that. And so I don't know if these are good positions or not, but they're a start. And so now what we can do is if we need to adjust the X and Y position, we can adjust these coefficients. And we'll plug that then in here for our geom text, where we'll do label X and label Y. And there we go. We've got our distance in meters and our time in minutes, and they are getting updated and they are pegged at a specific position. And it's centered at 80% of the height and 20% of the X. And so what I think I'd like to do is let's go ahead back here to our geom text, and we'll do hjust equals 0, vjust equals 0. So with this paste, I'm going to go ahead and do paste 0, and we'll do sep equals \n to put in a line break. So looking back up here at my mutate statement, I see that I did paste 0, but that my separator was actually outside of all of the pasting stuff. So let's try running Peyton and make sure that Peyton looks like what we think it should look like. And we get pretty at the end, so I'm going to go ahead and do a select on pretty. And so now what we see is not helpful. So let's paste 0. I think what we want, again, is paste. And so let's try looking at that column again. And now we see that we've got the distance, line break, and then the time. While I'm here, I may as well go ahead and put in the rest of my formatting. So let's go ahead and around distance meters, let's go ahead and round that. I don't need to have a bajillion points to the right of the decimal point. So let's go ahead and do round on distance meters 2. And so that'll round to 2 decimals to the right of the decimal point. And because we're testing this, let's go ahead and do select on pretty. All right, and so we'll run these lines. And so now what we see is that the distance was first, and that is rounded to 2 decimal points to the right of the decimal. But if you look at like 0, there's no decimals, but there should be, right? And so we can include here then format around that, and we can do n small equals 2. And so that should put at least 2 values to the right of the decimal point, even if it's rounded to only a single value. And so that 0 should now become 0.00. So let's try that again. And so now we see we've got the 0.00, but there is padding in front of that. And so I forget how to fix that. So if we come back and do look at the format documentation, there's a trim argument. And so we want to use trim equals true within our format. And so that is here. And we'll go ahead and do trim equals true. And let's go ahead and run all this code. And so now we can see that that leading space is gone. The other thing I want to do, though, is to paste. I'm going to have 2 steps of pasting, right? I'm going to have the distance as well as the time. We're going to want to do paste on that with meters, right? And so then this is all for this paste statement, right? And then we'll think about the time next. So let's go ahead and look at this. And it's got a problem. Where is it on unhappy? I think I forgot a comma at the end here. So let's try this all again. And so now what we can see is we have the distance with meters. And now we need to repeat this for the time, right? And so I'm basically going to do the same thing. I'm going to copy this down. And instead of distance meters, we're going to use the elapsed time minutes rounded. And the n small is 2. Maybe we want to round this to 1, because I don't know that we need hundredths of minutes. We can change this later, so we'll do then minutes here. And let's look at how this runs. And I'm forgetting something. Let's see. Where are you unhappy? So looking at the test, argument is missing with no default. Okay, that's not very helpful. And up we've got 2 commas, so let's try that again. And so we'll rerun this. There we go. And so now we have the distance and the time in meters with a line break in between. So now when we run this, we should be able to get our plot. Position lat doesn't exist. And that's because I still have that select on here. So we'll get rid of that. And let's try this all again. All right, so I'm kind of wondering if I want this right justified. I also wonder if I want a comma for the distance. So let's go ahead and do that. And so for our geom text, our hjust can then be 1 to get it to be right justified. And for our distance formatting, I think format has an argument, which is big mark. So that's like the 1,000 interval. And then we can see, we can put big mark equals comma within format. And so we'll go ahead and plop that in here, and we'll put a comma as the argument for big mark. And so let's go ahead and look at this, and we'll select pretty. And so now, let's look at the tail of this. All right. Good. Now we have the comma there. Good. So let's go ahead and run Payton, and we'll go ahead and regenerate our course and go ahead and render that GIF. I trust this is working, but again, we right justified it at the 20% position. So let's go ahead and change our position here. Let's bump that up to 0.4 or 40%. Okay, I'm pretty happy with the way this looks. I am thinking that like having meters down to the hundredths place is probably not necessary. It's probably not even necessary to have a decimal on meters. So I'm going to make this change, and then I'm going to stop fiddling with everything, okay? So let's go ahead and round distance meters to 0 values to the right of the decimal. And we'll go ahead and make that n small equals 0. And then that should do it for this particular part of the animation. I know this is taking a long time, but I think once we get going with this animation and getting it look good, we'll then have an idea for what to do with those two other animations. And so I think this looks pretty good. Like I said, I'm pretty happy with that. We could fiddle with the size of the text, but I'm not going to mess with that any further. Let's now look at the elevation plot that we're going to eventually put at the bottom of our plot. So again, we'll come down now, and we'll take Payton and pipe Payton to ggplot AES. And then on the X is going to be the distance in meters. And then the Y is going to be elevation in feet. And we've got meters and feet, and that really doesn't matter because there's no Y or X axis labels on these plots, right? It's all kind of relative. It's all kind of, I don't know, it's telling a story, right? Where we don't need the specific units. So I don't need to convert feet to meters, I guess is my punchline here, right? So let's go ahead then and send that to geom_line. So for some reason, this isn't generating the plot for me. I'm not sure what's going on with that. I don't know if I kill some of this stuff, if it'll work, but no, it's not working. So let's go ahead and do dev.off, and let's try that again. Okay, so I think I had to turn off the device. I don't know what exactly the device was that it was using, but anyway, I'm now going to go ahead and use the same kind of strategy that we used earlier to build the initial part of the course plot, right? And so I'll call this elevation.png. The width is going to be the same. I'm going to start with the same height. So let's go ahead and run this. And so here is my elevation plot. So like we did last time with the course, let's go ahead and remove all of the theming. So we'll do theme equals _ void. And while we're at it, let's go ahead and take this plot background to be black. And so I'll go ahead and plop that in there as well. And of course, we have the black plot because our line needs to be light gray. So I'll do color equals light gray. So that looks pretty good. One thing I'm going to do is to play with the aspect ratio. For my height, I've got 669. So let's go ahead and make that 300. And so that then really focuses it just on the line plot, which is good. And then, of course, we can come in here and do geom_point with all those same things again. And the color that we had for Payton up here was this green with size 1. So I'm going to use that again here. And so now we can see the point along the line. What I'm thinking, though, is I would like to put some of this information that Eric had at the top of his plot. I want to put it down here towards the bottom of the plot. And so that is going to be set with the caption. So let's go ahead and do labs caption. And let's put this on its own line and add that. And so I'll do XC sabermetrics \n by Pat Schloss after Eric Hill. And then I'll put in the date as 12/17/2024. We'll do cross country times 4. I don't know the exact year, so I'll put 20xxx NXN at Glendoveer Golf Course. So let's go ahead and see what this looks like. So of course, our caption is in black, so we need to change that. So we'll go ahead and do plot.caption, and we'll do element text equals, or color, sorry, equals white, and we'll go ahead and do hjust equals 0, because we want it left justified. By default, it's going to be right justified. So I feel like that text is a bit big relative to the size of the plot that we're going for. So let's go ahead and see if we can shrink that down a little bit. And we'll in here do like size equals 8. Didn't really do anything. Let's go down to 6. And so that's a bit more muted of size, and I'm pretty happy with the way that looks. Cool. Now we want to animate it, and so we'll animate it very much the same way that we did back up here. We'll grab this transition states, and we're going to give it the states based on the elapsed time minutes rounded. And I'm going to go ahead and grab this course GIF syntax that we had before. So instead of course GIF, I'm going to call it elevation GIF. So we'll name the plot elevation, and then we'll grab elevation and put that in there for course. And then let's go ahead, and the height needs to be the same. So we'll make that 300. So something weird happened. I've got the course GIF within the aspect ratio of the elevation GIF. And I see that, of course, I'm animated course. So this should be elevation. So we'll go ahead and plop that in, and let's try this again. All right, so I was getting a lot of the same types of warning messages that I was getting before. And I see that I've got my green ball popping around. And this reminds me that I forgot to change the syntax for geom_line, right? So remember up here with the course, we did all this other stuff, right? With the data equals nxn, inherit AES equals false. So let's do the same thing here for geom_line. We'll do data equals nxn, and we'll do mapping equals AES. We'll do x equals nxn, and distance y equals nxn elevation. All right, and then we also need to do the inherit AES equals false. So inherit AES equals false. Again, when using two different data frames like we are here, where we've got Peyton and NXN, then for geom_line, it's going to try to use the aesthetics that were set on line 53 here. And if we say inherit AES equals false, then that means we're not going to bring these aesthetics down into line 54 with the geom_line, right? And so basically we're saying, don't worry about these previous aesthetics. Don't inherit those, ignore those for now. So we'll go ahead and regenerate our GIF, and there we go. That's very slick. One thing I'm noticing is that our text is like right under the line, right? So like down here, this trough is basically at the top of the second line, right? I would expect it to be a little bit further down, and I would like a little bit more padding there, I think. And so one way of doing that would be to add some margin to the top of my caption, I think. So we can come back up here to plot caption, and we'll do margin equals margin. And then the top, let's try 100 just to see what it looks like. Okay, so that was too much. So let's maybe bring it down to say 10. And I'm also going to make it only one frame, so perhaps it renders a little bit faster. So that line now is up a little bit off the top of the second line. I think that looks pretty good. Maybe we want to put in some margin on the left side here. So let's go ahead then, and with our top, let's do L equals 3. And that then brings it over just a tad. Of course, we can't see anything because it's black on black, but I think that's going to be pretty nice. So let's go ahead and turn off that end frames equals 1 so we can see what this GIF finally looks like. And so now we see Peyton running across the course as that green dot. And of course, this is sped up a lot faster than ultimately what we want it to be. And we'll come back and deal with the speed later. So now we have the top, we have the bottom, and now we worry about the dial. So I think we're making good progress. All right, so I'm going to go ahead and grab Peyton. And you'll recall that what we're interested in is this heart rate BPM. And we'll do ggplot AES. And what we want is not something in chord Cartesian, but we want something in chord radial. So chord radial is a relatively new chord to ggplot2. Previously, it was called chord polar, but chord radial is replacing that. And so chord radial has some extra features that make it perhaps a little bit more advantageous to use than chord polar. One of the things is that we can basically make like a half circle. And so that's what I'm envisioning, is a half circle, kind of the top of the circle, if you will, where we have a dial, if you kind of think about like a speedometer on a car, or I don't know, wherever else you see these types of dials. So you can set the start position as well as the end position. And so those positions get set in radians relative to like 12 o'clock on a clock face. The other thing that's important to note is this theta equals x. So theta is really the aesthetic that we're going to be dealing with here. And equals x means, well, what should we be taking from up here in ggplot to use as the angle? And so what I'm going to use is that heart rate BPM. Let's go ahead and do a geom point, because that's going to be easier than probably what we'll end up doing. And so what I want to do is plot a point on the outer hub of a wheel. And so then our y is going to be 1, right? So the theta is going to be set by x, and the radius is going to be set by y, which is going to be 1. And I don't think it likes having that y equals 1 there. So let's go ahead and put that back up here in the AES where we normally put it. That works better. Okay, so now we see that we have a radial diagram where at 1, all the way around, we have a block point. And now we're ready to set the start and end coordinates. So let's look at the help for chord radial. And again, what we're interested in is start and end. And so start is going to be the position relative to 12 o'clock where our data is going to start. And end, again, is going to be in radians to the left, to the right, or wherever of where we're going to start. So a circle is 2 pi. Sorry to bring you back to trigonometry. So if 0 is at 12 o'clock, pi is going to be at 6 o'clock. And then pi over 2 is going to be at 3. And minus pi over 2 is going to be at 9 o'clock, right? So let's do minus pi divided by 2. And end equals pi divided by 2. We now have our half circle, which is fantastic. I'm really happy about that. But I don't want to have a dot moving around. I want to have effectively a line segment. If you could imagine where my mouse cursor is 0, coming out to the hub on the wheel at 1. And so to do that, I'm going to use geom segment. Okay, so we'll go ahead and do geom segment. And so geom segment needs a x end, y end. So x is going to be the radius, y is going to be the position on the hub, and then x end is going to be 0, and y end I'm going to make 0. And so basically we'll get a segment that goes from the center of this half circle out to the point on the hub, basically a spoke. And I've got too many parentheses here. Wow, that's awesome. What on earth did I do? That's not right. Okay. So what did it do? Maybe I will move these aesthetics back up here into my aesthetics with ggplot. This, my friends, on the right is what we call accidental art with a capital R. That's still not right. So I think I want my x end to be the same as my heart rate BPM, because that's going to be at the same angle, right? So basically everything is starting out at 0 as an angle, right? It's all coming this way, and then it's going to wherever. And so I think I need my angles to start at the same value as heart rate BPM. This is pretty wild to be thinking in polar coordinates like this. It's not something I normally do. There we go. That's much better. Now we have each spoke, if you will, is a different heart rate BPM, right? And so now what we want to do is start cleaning this up a little bit. And so one thing I immediately want to think about is that we have effectively a donut where we have space on the inside and outside. And we normally set this using expand. And so let's go ahead into chord radial and do expand equals false. And so that then gets rid of that expansion factor, and we then no longer have that donut in the middle or the space on the outside. Looking good. I would like to set the range and to perhaps have values along the outside of the hub at an even interval. At this point, It's kind of weird, and I'm not really sure what this is. Maybe it's like 155, that's 190. So I'd like it to maybe go up to 200, but I'm not sure what the minimum value should be. So let's do min on Peyton, $, heart rate BPM, and that goes down to 157. So maybe we could go from 150 up to 200. And so now the question is like, how do I do that? So if I was in Cartesian coordinate space, these values would be on the x-axis. And so I'm thinking that I maybe want to do scale x continuous. But that makes me feel a little bit weird because normally I use scale x continuous in Cartesian coordinates, but I'm using a different coordinate system, right? I'm using chord radial. So let's try this. We'll do scale x continuous. We'll do limits from 150 to 200. I'll go ahead and add that in. Hey, that worked. What do you know? Very cool. And so now what we have is we go 150, 60, 70, 80, 90, 200, right, by 10 BPM increments. And we've got our radius going out like that. And I think that looks pretty good. So one other thing I want to change is this heart rate BPM, which is the Y label. So let's go ahead and change that. So we can come up here and do labs Y equals heart rate BPM and add that in. So I think maybe it's the X that we want because that changes it on the Y axis, right? It's the X because X is what we're mapping to the theta, right? Okay, so it should be X. That makes sense. And now we have heart rate BPM there. Let's go ahead and make our Y equal null. That's good. Now we don't have that Y there anymore. One other thing I want to do on this plot while we're still in kind of black and gray and white space is I want to change the color of the needle. And I would like to make it the same green as what we're doing for Peyton in the 3 other elements. So we'll do color equals green. It doesn't look great on that gray background, but I think when we make everything black, that'll look a lot better. And so I'm then going to go ahead and maybe one by one turn all these factors to be white. And so let's do that with theme. And so I guess we could one by one turn everything to be white, or we could make everything void, theme void, and then make it white. I think that's what we'll do. So let's go ahead and do theme void. Again, that gets rid of everything. So let's go ahead then and add in theme. And we'll then go ahead and do plot.background. And we'll do element rect fill equals black. That gives us a nice black background. Again, we have that issue with the aspect ratio that we may or may not need to worry about later. I'm going to go ahead and turn off some of the y-axis text. We'll do axis.text.y element blank. And maybe what we could do is maybe look at some of these things without the theme void, right? Or maybe without that plot background. And so we can also get rid of those tick marks. So we'll do axis.ticks.y. That's a y tick mark. It's kind of hard to think in this coordinate scheme. Blank, so that goes away. And then our x-axis values, we want to be white with white tick marks. So we'll go ahead and do axis.text.x element text. We'll do color equals white. And then we'll also do axis.text or ticks.x equals element line color equals white. Got an extra period there for some reason. We need to make our heart rate to be white as well. So then we can do axis.title.x equals element text color equals white. And basically what I've done is to make theme void on my own, right? And so if I put this back to plot background, what's that going to do? Well, now I still have these grid lines, right? I can go ahead and do panel.grid equals element blank and panel.background. And let's make that element rect fill equals black. Great. So I think this looks the way we want, and we're able to do it without having to use theme void in the end. We can either take things away or we can add things back. And I think, like I said, I think this works pretty well. And for some reason, I've got I need to fix my indentation here, which I could probably do with RStudio, because someone's going to send me a message and say, Pat, you could just reflow your code. So reindent lines, Command I, that gets that to work. Okay, cool. Now we need to animate this, right? And so we'll again do this transition states, throwing that on. And one of the things that maybe you've noticed is we didn't have to do that trick with the NXN, right? And so we used NXN up here, and I did give it heart rate, but I don't think I actually need that heart rate because I'm not using NXN for this BPM heart rate monitor dial thing, right? So anyway, so let's go ahead and animate this and see what it looks like. So I think that looks pretty cool. I think we need to make the line thicker and the text bigger, and we need to fix the aspect ratio. So let's go ahead, and before we get going with the animation, let's go ahead and use the strategy, be patient, that we've used before by saving this stuff to a PNG. So I'll call this heart rate BPM. So I don't want it to be 1100 by 300. So let's go ahead and start with like 300 by 300 and see what this looks like. I need to give that the PNG to tell it what format to save it as. All right, so that's compressed down in probably too much. But again, this is why it helps to do things in the actual size that you want to be working in, right? Let's make it 400 by 400. So I see a couple things. We have a white border around the plot. And then we also have the aspect ratio not quite looking right. I'm going to take on maybe the aspect ratio first and then remove that white line. And then we also need to make the text on this x-axis text to be a little bit smaller. So again, let's deal with the aspect ratio, and maybe let's drop that height down to 300. Wow, that was pretty easy. That got us really close. So let's maybe take it down to 290. All right, I'm going to fiddle with it. I'll be right back once I've got the right dimensions. So I think that looks pretty good at height of 295. Let's go ahead and set the border to be black as well. So we'll do color equals black, and it must be the plot background that needs to have color equals black. All right, very good. We now have that nice black background. It does appear to be a bit pixelated, and I think that's because everything is so big. And ultimately, I think on the grand scheme of things, it's probably going to be more about that size. And so let's go ahead and make the text of the numbers smaller and see if that doesn't give us maybe a little bit more space. We're certainly getting kind of the numbers clipped on the left and right. So that was in axis text X. And let's do size equals 8. All right, that wasn't 8. Let's try 6. So that's bringing it in a bit. Let's go ahead and make it 5.5. So I think that looks pretty good. So let's go ahead and save this as the heart BPM plot. And then we can put this back to being an animation like we tried to do earlier. I'm going to grab this elevation GIF stuff to copy it down. gganimate is something I think is really cool, but it's not something I work with every day. And so it's hard for me to remember all the syntax. So when it's something I don't remember all the syntax of super well, I end up doing a lot of copying and pasting. So hopefully that doesn't bother you. So we have heart rate BPM GIF. We need to switch out elevation to be heart BPM. Let's go ahead and do 1 frame. And then we'll go ahead and put that heart BPM GIF as the output. And it's upset because why? Because maybe I didn't run this. There we go. I forgot to load the whole plot with the transition states included. And I forgot to change my width again on this thing. So this is the problem with copying and pasting, right? All right, let's try this one more time. I do see a bit of that letterboxing effect. Also, in this view, there's space to the left of 150, but there's no space to the right of the 200. So let's go ahead and take care of the letterboxing first. So let's make this maybe 294. We can probably go down further. Great. So 293 did it. Again, we've got a bit of clipping on the 200 and extra space around the 150. And so I wonder if the margin isn't quite right on the plot. So let's try that. Let's try plot.margin. And let's do margin. And I'm going to assign zeros all the way around because I don't really know what the defaults are or where it's causing problems currently. I'm not really sure what to make of this margin issue. So it looks like there's no margin to the left, but we're missing some margin on the right. So why don't we add some margin to that heart rate BPM? So the first is T, the top, then the right, which is this, right? So let's go ahead and put that at 10. So now it looks like we have too much space. So maybe we'll cut that back down, maybe to 5. All right, there's a little bit of clip. So let's increase it back up to 6, and we'll probably be good there. We can then reassess the aspect ratio. Okay, that looks great. Now we need to worry about the aspect ratio. I'll be right back once I've got that figured out. All right, there we go. I think that looks pretty good. And I got from, I think I started 293 and we're at 259. Anyway, we now have our 3 GIFs, right? We have our course GIF. I'm going to go ahead and comment out these different lines that we're not using. We also have our elevation GIF, right? And then we have our heart rate GIF, right? Again, we have course GIF, we have elevation GIF, and we have heart BPM GIF, okay? So these are 3 GIFs, and we now want to basically compose them together, right? So the one that's going to be easiest to think about is having the course GIF on top of the elevation GIF. These, by default, the output of Animate generates 100 images, 100 PNGs, right? And so by default, we see end frames defaults to 100, and it's 10 frames per second, right? So the original video from Eric was 2 minutes, 32 seconds. So basically 152 seconds, right? And so we'll probably want to change that duration to 152. So I'll write that down here. So duration equals 152, okay? And so we'll want to compose these together. So again, course GIF, elevation GIF has 100 images in it presently. And we're going to use image magick. And so we'll come back up here and do library magick. And it links to image magick, which again is a great tool that works from the command line. To install magick, you might also have to install image magick. It's definitely worth your while. And if we come down and we think about, again, like course GIF 1, but if I look at my preview, this is what I've got. If I look at elevation GIF, that's our elevation. And so we want to pull these together. Within image magick, I could do image append, and I could do both of these, right? So I'll plop that in. So I can then give it those as a vector. And so then it'll take this vector and it'll append those 2 images together. But what you notice is that it does it left-right. And so we need to give it a special argument, stack equals true, for it to then stack one image over the other, right? And so now we have this image, obviously, on top of this image. And what we can begin to think about is putting our dial diagram right in here. Let's go ahead and call this course underscore elevation. And I'll put this on separate lines so it doesn't scroll off the right side. All right. And so now what we want to do is we want to do an overlap of the heart BPM GIF on top of the course elevation GIF. Again, we only have one image in this GIF so far. We can now do image composite with course elevation and heart BPM GIF. And I'm going to give the first element of both of those vectors. And course elevation not found because I probably didn't run it. All right, now let's try that again. So now we have our heart rate monitor right on top of the upper left corner of our overall plot. And so if we look at the help for image composite, we'll see that there's an offset, so +0, +0. And so let's scroll down and look at offset, string with either a gravity type or a geometry point to set position of top image. And so let's see if this gets us anywhere. And so as a geometry point, left offset in pixel, top offset in pixel. So we can say offset equals, and then plus, so the left and the right. So remember, we're 1100 wide, and I forget what we are deep. But let's go ahead and start with like +800, and then let's come down 200 from the top. And so we see that that's moved that over here. And I want it to be, I don't know, right over here, perhaps a little bit more. So we want it to be to the left and down. So let's go ahead and do plus 700. All right. So I'm starting to see that there's going to be a problem with this being overlapping our course. So let's drop it down a little bit. So let's go down to 300. That's kind of a good position, but of course we're overlapping with our course. And what I'd like to do is maybe bump it to the right a little bit from here. So let's do 800. That's probably too far. Let's do 750. There's a lot of bumping in here, right? All right, we can probably come back to 725. Okay, that's too far. Let's go 740. All right, you get the point, right? For all this bumping and moving things around, we need some extra space on the right side of our plot. So to make it wider so that we have room for the heart rate monitor, I'm going to change the x-axis scale, the scale x continuous on this course. And so I'll come back up here and we'll do scale x continuous. And we'll do limits. And I'm going to do NA for the left side. So NA is going to allow our scale x continuous to pick the appropriate left end or the lower end bound. And then I'm going to give it the upper bound. And so previously we had what? We had x range, right? So we do x range. We get -4, we get this and this, right? So this goes 14617. I'm going to remove these 4 values at the end and basically round it, right? And so let's go ahead and put that in with 4 extra zeros here instead of that 645. No error messages, and that got us some extra space. What do you know? I'm a little bit perturbed that that didn't actually work, and I'm not sure why. Actually, let's see what the ratio is of this to x range 2. That's really close to 1. And so I think maybe what happens when I'm multiplying x range 2 by like 0.9 is that it's just like really far out to the right. And that makes everything really thin then when we look at that aspect ratio. So I'm going to go ahead and change this x range 1 to be an NA. So let's go ahead and turn our animation back on and go ahead and comment out our ggsave, load our GIF, and then we'll go ahead and come back to making the composite image. There we go. And so we need to fix the aspect ratio of our plot. I'm going to go ahead and do that real quick so you don't have to watch me fumble through doing all this. All right, so now we got rid of the letterboxing and we used a height of 629. Now let's come back and try to do our composite imaging. Cool. And now let's try moving our heart rate monitor to the left a bit. And so again, that was this first number. Let's put this down to 700. And I think that actually is right about perfect. We can maybe move it to the left just a smidge and maybe up a bit. So let's do 690. So maybe I'll move it back a little bit. I think I'm kind of clipping it just here a little bit. So let's make this 695. And I think that's great. All right. So now we've done our compositing for the first frame. Now we only have like 1,000 more frames to go. Right? So I'm going to go ahead and grab all of my GIF statements and I'm going to pull those down here. So I have everything I want to work with. I'll get this elevation GIF as well. Plop that there. And then our heart BPM GIF is here. And maybe I'll get rid of these commented out bits of code. And I have end frames of 1. So let's go ahead and we'll leave all that, right? And so what I need to do is build out the number of frames that I want, right? And so the number that I want is basically, if I take nxn, how many rows does that have, right? So it's n row. So it's n row on nxn, 1148. And so this is n frames. Is that, and so then I'll pass n frames and here in place of 1. And then I also want to set the duration. And so the duration, and so that is 152 seconds, right? And so then we'll do duration equals 152, and we'll copy this down for all of our GIFs. All right, and so this will make sure that each of our GIFs has 148 frames in it, right? Because currently they only have one, right? And we also want to set the number of frames per second. Although I think if I do animate, I think the duration will set the FPS. So duration, the length of the animation by seconds, unset by default. So I guess I could do, if it's 10 frames per second as the default. So if I have 1148 divided by 152 seconds, that's like 7.5 frames per second. So I could do FPS equals 7.55. So maybe that might be better to do. And let's use the arrow because we're using R, right? So let's, instead of duration, let's do FPS equals 7.55. And actually, let's make this a calculation. So we'll do n frames divided by duration. All right. And so then we'll make FPS equals FPS. And this is what we'll use instead of duration. And what is it upset with me about? That works. So FPS. Oh, FPS. Okay, there we go. And so now we want the same thing down here. Cool. So let's go ahead and load all of these. All right, so it's unhappy about my frames per second. So I'm going to go ahead and put this back to duration. Let's see if it'll do that for us. All right, so it appears to be upset with my choice of FPS, but I don't set an FPS. So maybe what I will do is hard code some of this stuff. So let's go ahead and set the frames at 1,000 frames, and we'll set the duration at 150. And I realize I didn't put the duration in here as well. So let's go ahead and load all that. And let's try this again. Seems a little bit temperamental. And so that all goes through. I should point out that running each of these commands takes about 30 seconds to go ahead and build basically all the images for the GIF. And so now if I look at like dim on heart BPM GIF, well, it says null, but let's see if we can do like a glimpse on that. We see that it's got 1,000 observations with 9 variables, right? So basically we have 1,000 frames, and it's got 1,000 frames. And so now we need to take the 1,000 frames from each of the 3 GIFs or data frames and bring them together like we've already done for the first one. So this is going to be coarse elevation. So now we want to kind of build it out for the other 1,000 frames. So we'll do for I in to length on coarse underscore GIF. And this length of coarse GIF should be 1,000, right? So we're going to go from frame 2 to 1,000, and we're going to concatenate that all together. So we'll make kind of a dummy, which is going to basically be this, except instead of 1, it's going to be I, right? And then coarse elevation is going to be appending coarse elevation with dummy at the end, right? And so some of you are probably thinking, oh my gosh, you're using a for loop. You're growing vectors and data frames. Yes, I know. This actually isn't going to take that long. So we should be in pretty good shape. So let's go ahead then and run this. And so if we look at coarse elevation, we now get our GIF moving at an appropriate speed and not just wildly just whipping all over the place, right? And so this looks pretty nice. Now, of course, we need to add in the dial. So we'll do the same strategy that we had here. So again, we have image composite. I'll call this coarse elevation BPM equaling all that. And then let's put this on a separate line, okay? And so now we're going to do another for loop. And so we'll do for I in to length. And then let's do heart BPM GIF. That should be 1,000. It is, good. And we'll then go ahead and then do dummy equaling this image composite, right? But instead of 1, we want I. All right. And then we're going to go ahead, like we did up here, and concatenate together our course elevation BPM with that. And so now what we run lines 123 on down, this then should add in the dial to our GIF. And so again, we run that, and here we go. We have our dial right next to our course with the change in elevation. Awesome, right? So I think this looks really nice. Maybe we could fiddle with the size of the plotting symbol as a kind of Peyton runs through the courses and everything. Maybe I'll mess with that before I finally post the code so you can see the final version of all this. One thing that we need to do, of course, is to save this out to a file. And so within Image Magick, we can do image write, and we're going to write this file, and I'm going to call this nxn animation.gif. Run that. This will then write the GIF out to disk, and we should be good to go. So this is the GIF written out to disk. It's about 58 megabytes in size, so it's not small. And I think it's pretty cool. Like I said, I would probably make the plotting symbol a little bit bigger so that it's easier to see. One of the other things that I noticed is that when Peyton gets to the end of the course, it goes back to the beginning. We can change that by coming back to our GIF statements, and in here within Magick Render, we can do loop equals false, and this will not force Peyton to keep running the same race. So basically, once his icon gets to the end, the GIF is over, right? So that's cool. And again, I would probably come back up to the course. Where did I have that? Here with geopoint size equals 1. Maybe we could increase that to 2. And then down here with the elevation, I have size equals 1. I'd probably make that 2 as well. I'm not going to force you to stick around and see how this all resolves itself. I'll go ahead and run that. And maybe at the end of this video, I will put on the 2.5 minutes of Peyton running the course. I hope you've really enjoyed watching me build out this animation. I know this is a longer video than I normally make here. I am releasing this the week of Christmas and Hanukkah, and so this is my present to you. I do celebrate Christmas, and so maybe one little way I can give back to you all. Hopefully you got something out of this, even if you don't make animations. But I would encourage you to think about, time is a really interesting variable, and being able to use time to build out an animation, I think is pretty slick. So anyway, let me know what you think of this video, this GIF. Let me know if you say GIF or GIF. I tend to say GIF for whatever reason. And again, enjoy this. Let me know if you have ever tried to make an animation and how that has gone for you. Anyway, I'm exhausted. I'm ready to go do something else. And we will see you next time for another episode of Code Club.